let's mint some xBTC. So what we need is we need to set variables for this spell, and then we can try to prove it, and then we'll submit it to the Bitcoin blockchain. Okay, so first, what we need is so we already have app ID and app VK. Let's make sure that we do. And app VK is the verification key of this app contract for xBTC, which is coded right here. But let's get back. App ID is the identifier of this fungible token, and ID, we do have it. And let's see. So now what we need to do is we need to get our lock funds transaction ID. Let's do that. Okay, so just to make sure that that's the transaction ID that we want. So we want to decode raw transaction, and let's just lock funds TXID here, and let's see what it is. So okay, so that transaction actually creates a few outputs. The output number 0 is the one Bitcoin that has been locked, and now it's in the Bitsnark contract. The last output is supposed to be 1,000 sats. It's the one that we can spend in order to mint xBTC, and the rest is change. So we're spending a few inputs, and we're locking in one Bitcoin. We're creating the what we call minting output, which we will spend, and that's exactly what will happen. So okay, so we exported that variable and have just checked that it's pointing to the right transaction. So what now? So have and we need to get the log funds transaction X encoded. Well, that we can do like this. Get raw transaction. We already have this command here, which we will reuse. Export, and that's supposed to get us that transaction in hex form. Log funds txx. That's it. All right. Now we have this. Okay, what we need is another address. Oh, that shows. It's another address. Okay. I'll just get new address. And looks like we have our we have filled our template, and let's just test that. App spells xBTC 0 mint and substitutes. Okay, let's look at it as JSON. UTXO JSON. I believe that's the command. Oh, actually, this is pretty cool. We can see grep null. We do have a bunch of nulls here, so looks like we forgot about the locked amount. Pretty important. Locked amount is 1 Bitcoin, so that's going to be 1, 1, 2, 3, 4, 1, 2, 3, 4. All right. Let's repeat. Okay, first of all, no nulls. What do we have here? So we've got 2 apps, one for the fungible token. That's going to be our xBTC. I mean, that is xBTC. And the other is what is called a, what do we call it? We call it xBTC batch or a payout voucher NFT. So that's an NFT that represents the amount of xBTC minted. So, and we have exactly one output. In that output, we have 2 charms, and one of them is the xBTC batch, and another one is actual xBTC. And you can see the amount is 100 million sats. That would be 1 Bitcoin. So let's go ahead and check this. And run. So this is going to be, this is going to just run the app to see if the transaction satisfies it. It does. Let's do the actual check. So now we have, okay, so let's see what we have. Binaries. Okay. So this app binaries thing is where our compiled code for this app contract resides. It's an RISC-V ELF executable. Okay. So just to let you know where that is, bins, it's right here in the target directory. Okay, so looks like the spell checks correctly. So let's try to cast it. So what does casting a spell mean? Well, casting means we prove the spell. So we create a zero-knowledge proof of this spell, meaning that any previous transactions carry correct spells. We don't have that. We are spending a locked output, and it doesn't have any charms in it. So locking transaction, Bitsnark locking transaction doesn't have any spells. And another thing we want to prove is that all application contracts are satisfied by the transaction. And then we wrap it into a GROS16 proof, and we will put it inside a transaction as data alongside our spell data. So let's see, what else do we need? Just cast. Let's just see. Okay, funding UTXO. Yeah, pretty important part of this is we want we want to fund this transaction. All right. So how we do that is we will choose a funding UTXO out of unspent outputs. So here's unspent. Okay, what do we have here? So let's see. We cannot spend this one, the DC2 to 2B42, the 1000 sats. We absolutely can't. And we need to spend an output for funding that has sufficient amount of funds to fund, well, the Bitcoin transaction, actually 2 Bitcoin transactions, plus brewing fees, which we will get back to ourselves. But anyway, okay, this looks promising. Okay, let's see if that, just make sure that it doesn't carry any spells. So spell, and let's put in that transaction ID. Oh, it actually does. Well, but let's see if, okay, this is output number one. The output number one is empty here. We only have charms in output 0. So I believe we can spend it. Okay, so let's put in the funding UTXO ID. That would be output number one of this transaction. And with that, I believe we can send the command to create a proof and 2 signed transactions with our wallet to mint xBTC. Let's go ahead and do it. Okay. So we've got our 2 transactions. Let's first just check that this one gives us what we want. So we need to show spell in a transaction, and we don't need to get it from blockchain. We just need to paste it. Let's see. All right, and just to make sure. Okay, so that's the correct transaction ID. Okay, I believe we can go ahead and submit this. So we will copy that and let's do submit package. Okay. So now our transactions have been submitted to the blockchain. Okay, so I just want to share the blockchain explorer. So this is mempool.space. This is our locking transaction that locked our 1 BTC. This is our minting output, and let's just refresh it. And now it is spent by this transaction that has just minted xBTC. All right, this is huge. Okay, and what is this fat thing? Okay, that's the remainder of our funds from funding this transaction. Awesome. Okay, next up, let's just see if we have the charms in that transaction. Just okay. So now, all right, now we're getting the transaction from the Bitcoin node, and there we go. So, okay, as we can see, what we have here is an NFT that identifies the batch of minted xBTC. Well, this is the token app identity, and this is the batch ID, and it is exactly the same as the minting transaction, rather the lock funds transaction that locks our 1 Bitcoin. And when we burn this batch, this ID will be used to say, okay, we're burning this particular Bitcoin. Okay, now that we have some xBTC, we want to send it somewhere. Let's do that. So we have minted, and now we want to send it to our friends on Cardano. And okay, so let's look at this this spell here. So what is going on here? So we have one input that has two charms, the NFT and the xBTC, and we want to separate them. NFT goes into a Bitcoin address, and the xBTC tokens go to Cardano. Okay, so for this to happen, we obviously already have these set up. Well, first we need this the minting transaction ID to identify this input UTXO ID. So we will. Oh, by the way, let me just copy everything here in this. I'll just select everything. Continue. Okay, now I can clear this. And okay, so we've just sent that transaction, and let's export x0 equals the minting transaction. Okay, what else? Okay, so we have everything here. Okay, we need a new address. Address equals, we got the address. And let's see. Okay, so this one is another address on Bitcoin in our wallet. But since we are going to send to beam this to Cardano, we need a UTXO on Cardano, which we will get in a second. And we need a hash of that UTXO ID. So I have a few wallets prepared here. So I've got wallets for our friends at Sundial and Handle. And the first up here is the wallet for Sundial. Let's see. So I have a Cardano Explorer here. And let me just put in the address in there. And how can I make sure that that's the correct one? It must have something interesting inside it. Oh, so it has a handle, Sundial. That looks good. And what else? So we need a transaction output of exactly 1 ADA, which is 1 million Loveless. And that seems to be it. Okay, so it's great to have this. And let's just make sure that that is correct. So let's see. So I got my little cheat sheet here, and just like this. And what I want to do is I want to take the CBOR, or actually the hex form of the transaction. Okay, I'll copy the transaction ID and I'll paste it here. And here's how I got the. Oh yeah, it doesn't seem to have anything interesting in it, which is great, because what do we want? We want a transaction without any spells that creates a small amount of ADA, and into the output of this transaction, we will beam our tokens from Bitcoin. So well, let's just make sure that we can do that. Let's show spell. And that would be paste, and that would be chain Cardano. No spell found in the transaction, unsurprisingly. So anyway, let's get back to that Explorer. Okay, I just want to copy this transaction ID again. And I'll be back to the Explorer. That'll be output 0. Okay. Okay, so we want a hash. Okay, I've written a little tool to hash UTXO IDs in convenient form. Let's try it out. HU means, or hash U. Hash U. There we go. Let's see. Same thing. And okay, so we want to set this. So meaning export this variable, and Let's put our little command in here. Okay. I think we are done preparing the data for this transaction. Let's see if how this works. So first of all, let me select all, copy, save the logs, and xBTC1. Okay. Like here. Output. So let's see. Specifically, we're looking for nulls. No nulls here. Awesome. So we can proceed to trying it out to run the app against this spell. Looks good. Okay, let's check. Okay, this is all right. Checks out. So now what? Now we cast it. Okay, let's see. Okay, finding UTXO again. Oh, it's a different one this time. So let's oh no, no export. Finding UTXO equals, and which one is it this time? So um, um, I believe this one looks good. We can also use this one. Okay, let's see if this one works. It's output number one. And just to make sure that we are not, okay, no spells, that's good. So at this time, we're not gonna spend anything dangerous because we have already spent our minting output from the lock funds transaction. We obviously cannot spend the 1 Bitcoin, which is locked by Bitsnark. So at this point, any spendable UTXO is fair game, and our CLI will not allow us to create a transaction. It will not pass the check if there's something wrong with that input. So let's go ahead and use that. And let's see. Funding UTXO. All right. And let's go ahead and prove it. All right. So at this point, we have created the two transactions with a proof of spell for sending out the xBTC. So let's first check that the transaction indeed has the spell on it. Spell, and this one's obviously on Bitcoin. So yeah, looks correct. Two outputs. First is sending the NFT, the batch NFT to a Bitcoin output, and the second one sends one Bitcoin, or rather one xBTC to an output on Cardano, and this is the hash of that output. Okay. All right. Let's copy all of this and submit to Bitcoin. Okay, and our submission was successful. And let's check that the transaction actually is gettable by ID and has the spell. Okay, we have it now. Okay, so now let's again select everything, copy to the log. All right, let's continue. So at this point, we have our tokens beamed out to Cardano, and this means our friends at Sundial can spend that output and send it to someone else. Okay, so that's exactly what they are going to do. We're going to help them out, though. Okay, so what our friends are going to be doing is they're going to take this spell template and fill it in. So we already have app ID, AppVK, and I believe we have input UTXO 2 already exported. We have the locked amount, and we need this transaction ID that we have just. I believe it's this one. Okay, let's just check. Yes, that's exactly the one, and we want to export the X1. Okay. What else? And the next interesting thing is we're going to need an address on Cardano, and that's going to be the address of our other friends on Cardano, the project called Handle. So let's see. All right, address 3, and let's just go ahead and see what that is. Okay, hopefully you guys can see. Okay, so I believe we have this address, but let's just check. It must have a handle in it. Okay, actually, let's open up a different tab and paste this address in there. Okay, boss handle. Oh, okay. So what do we have here? We have a couple outputs. So one is obviously the handle, and the other is we have about, well, precisely 4 ADA here. We're probably going to need it later. And okay, and this one is the Sundial address. Okay, so what we're going to do, we are going to take this address right here and paste it here. All right. And with that said, looks like our spell template is filled, or rather, the data is now in there. Okay, let's go ahead and check that out. Spell xBTC 2. All right. Okay, do we have any nulls here? I don't think so. All right. Let's run the app and see if everything works. Okay, so this transaction is going to happen on Cardano. So let's spell check. So for Bitcoin, we have some automations in place in the CLI. For Cardano, a bit less so, because I have just implemented Cardano support. So we are going to need to provide previous transactions to the charm spell check command, and that would mean the transaction that created the output that we're spending on Cardano plus the beaming transaction that we have been beamed the xBTC from. So let's see. Equals. Okay, we're not sending that yet. We're going to need this variable right here. And let's set it. Okay. How are we going to do that? So about that first output. Okay, so here's the transaction ID. We will need that to get the transaction in its hex form. So that will be in the cheat sheet here. Um, um, okay. Copy this. Paste here. All right, here's the exit coded transaction. We'll paste it right here into this previous TX's variable. Another one would be the Bitcoin one. And for the Bitcoin one, we actually can just get it from Bitcoin CLI. And for that, we just need the transaction ID. Okay, we got it. And it's transaction. Come on. Let's paste it. Ooh, it's a pretty big fat transaction. Okay, so now we have these two. Let's see what else we do need. So spell check. Let's just check the command history. Check. Okay. Okay, Cardano. That's what was missing there. Okay. Bins, brief TXs, and chain equals Cardano. Okay. Copy this command. All right. Oops. Yeah, right. Forgot the value for this. Okay. So, okay, just to recap what just happened. So we checked the entirety of this spell, and let me just get that back from the command history. And oh, so this spell right here, we're sending on Cardano xBTC, the 100 million satoshis of xBTC on Cardano from a UTXO that this xBTC was beamed from Bitcoin to, and we're sending that to another Cardano address. Okay. Haven't sent it yet. So what we need to do, we need to prove the spell. This will create a Cardano transaction. For Bitcoin, we need 2 transactions. For Cardano, we only need one. And we're going to need to sign it later. So spell prove. What else do we need for this? Let's just, again, consult the command history. Spell prove and see what we need. Okay. Okay, we got app bins, that the application binary, the previous transactions, chain Cardano we already have, funding UTXO. Okay, so we need a funding UTXO for in the wallet of our friends at Sundial. Let's go ahead and find it. Okay. Okay, which one are we going to use? This looks promising. It's exactly 4 ADA here. And I don't believe it carries anything. So this one is the beamed xBTC, but this one looks good. And again, which one? It's output number 0. Okay. Okay, what else? Funding UTXO. Funding UTXO value. All right. Let's see. Well, in our case, that's going to be 4 million. What else? We're going to need to change address. Well, change address is obviously going to be the same one, the same wallet right here. Let's just copy it back from here. Which was the same one. Yeah. Change address. And I don't think we need anything else. Okay. And let's just double check, what is this address right here? It's supposed to be the one that belongs to our friends at Handle. 7UW. Yeah, that's the one. Okay. So we should just go ahead and approve that transaction. Okay. With the rest of this stuff. So we're proving the spell sending xBTC from one Cardano address to another Cardano address right now. All right. Okay, so let's just quickly make sure that this transaction indeed contains the proof. Okay, show spell. So we want this on Cardano. Short and sweet. It does. Okay, so we need to go ahead and take this save it to a file, sign it, and send it. Okay, so let's go to another window here. Okay. So let's first of all take this transaction and put it into this file. Okay. Yeah, that's the one. Okay, now um, so now we want to sign it. And how do we do that? So, okay, let's use again a cheat sheet here. So we have, okay, so we need the wallet directory. Let's set the wallet directory first. Wallet directory equals, okay, so we've been sending from Sundial to handle. That would mean Cardano wallets Sundial. And that, let's go ahead and copy this. Okay, we have this TX draft JSON, and it's going to land in TX signed JSON. Okay. Okay, let's see. This is the signed transaction. Let me check real quick. It's still the same one, but signed. And now what should we do? We should take a look from the Cardano CLI point of view, what that transaction looks like. Okay. I think it looks good. So CR 1A, the output, that's going to contain the charm with xBTC. This is the change output that also contains the datum describing the spell and the proof. And yeah, let's take another CLI command and go ahead and submit it to the Cardano blockchain. Oh no. Okay. Looks like Cardano thinks that the output with our spell and proof is too small. So we need to prove that transaction, prove that spell again. And we could not submit that transaction, so our funds are safe. So let's just repeat that, but simply with a different funding UTXO. Funding UTXO equals. Okay, so we're taking this one and output number 0. And you equals, it's going to be 10 million loveless. Yeah, so 10 ADA this time. Let's see if that works. And let's see if we need anything else. I don't think so. Okay, let's just make sure that change address looks good. Um, so the change address, let's see. That's 597Y. And yeah, that looks good. Okay. Let us send, let us prove this again. So yeah, we had a minor hiccup. Indeed, the Cardano blockchain considered the output value of that output with the change of just below 4 ADA with our spell and proof insufficient. So what I did was I sent 10 ADA to that wallet, and I have reproven the transaction using that 10 ADA output as the funding UTXO. And what has just happened is I have created that proof. I've put that into this TX draft JSON, and I have used the Sundial's wallet to sign it. So here's the command to sign that transaction. And then, okay, actually, this is the command, the correct command here. So then we looked at the transaction from the point of view of Cardano CLI, and let's review it here. So the fee is 250,000 loveless. These are outputs. The 1 ADA output that will carry the charm with 1 xBTC, or rather carries that charm already. So we have the change output of just below 10 ADA with the datum on it that contains our spell and proof. And that sums up to, I believe, 11 ADA, precisely. Now that transaction was signed, and here's we have successfully submitted it. So yeah, let's see if okay. Let me actually also take that transaction in the Explorer. So I'm going to look at my Cardano Explorer here. So I did indeed receive the output here. Okay, so what I'm going to do is I'm going to copy the from my cheat sheet a block frost API command to fetch that transaction into the CLI, and I will do that, and I will paste in the transaction ID from the output that was just received. That would be 1 ADA. Okay, let's see. Let's do it again. And let's paste it right here. Okay, so that looks about right. And we'll take that and we'll run the show spell command on it. Yes, that's exactly the one that we need. Okay, so we did it. We have beamed one xBTC to Cardano, and we have just sent that xBTC between two Cardano wallets. Next up, sending that xBTC back to Bitcoin. Okay, so that means that our friends at Handle are going to send the xBTC from their Cardano wallet to our Bitcoin wallet. And that involves a transaction on Cardano that will beam the Bitcoin, or rather xBTC, to an output in our Bitcoin wallet. So for that, we will need to have a spare output on Bitcoin, and we will need that output to not have, we'll need that transaction, creating that output, to not have any spell. Okay, so let's check this out. So first, we'll need to list unspent outputs. And let us see what we have here. Okay, so we have a bunch of outputs with precisely 1,000 sats in them. And okay. So let's look at them. I'm just going to look at each and every one of them and see if we have a spell in that transaction. Okay, we got one here. That's the one that created the xBTC reference NFT, by the way. Okay, this one doesn't. So we're going to use that one. And okay, so 1,000 sats output. Okay, so it's going to be the transaction ID. Okay, wait a second. I need to export this and then take that transaction ID. And I believe that was number 2 here. Okay. All right, let's also export the hash. I simply want this. Okay. And we obviously need the address here. Okay, so we also need this transaction. Um, okay, let's take a look at that. Okay, export times 2 equals this. I believe that's the correct transaction ID. And let's see. I also need this address. Um, address 3 equals. Well, that's the thing. The handle wallet is going to send is going to beam these tokens to back to Bitcoin. So there's no need to send any ADA around. So we technically could simply just use the same Cardano address, or we could use the boss Cardano address. Maybe let's do that. Okay. And I believe we have all the data. Maybe we don't, but let's check it. Okay, that can be xBTC 3. And let's just see this. And we're looking for any nulls here. No nulls, meaning that all the data in this spell is filled in. Let's just be extra careful on what we are spending here and where we are sending these things. Okay. And let's okay. Okay, just once again, let's make sure that this transaction does not carry a spell. It doesn't. And let's see that it's the correct hash. Yes, it is. So looks like we're ready to give it a try. So beam back, and let's start with running the app against this spell. Okay, the contract is satisfied. Now let me quickly check. All right. Okay, now the usual stuff here. Oh, but we do need to copy the previous transactions. So UTXO equals, and let's go and do that. So what do we have here? So we have, obviously, we're spending this UTXO here. We want that transaction, and actually already have that transaction. So let's just paste it in. Another thing that we need is we need the transaction for the UTXO, which we are beaming the xBTC into. So that would leave, I mean, transaction of this one, and let's just go ahead and just go ahead and fetch it. Okay. So spell proof. What else do we need to take care of? So we have add-ins, brief TXs, chain Cardano. We're gonna copy that. Funding UTXO, of course. So first of all, let's take that, and so we are now in the boss handles wallet, and I'm gonna go and check my Cardano Explorer here. So I do have a transaction with 10 ADA in it. That should be sufficient. I'm gonna get the value. Did I say 10 ADA? Okay, 1, 2, 3. 1, 2, 3. That's 10 million Loveless. That's 10 ADA. Okay, what else? And the change address, obviously. Change address. I'm going to use, since we are in the handle wallet right now, we're going to use the handle wallet as the change address. It's going to be this. And now, okay, wait a minute. Oh yeah, we haven't completed the spell check yet. Let's check the spell. So for that, we don't really need much. We do need the previous transactions. And let's run it. All right. Okay, now that the spell looks correct, let's prove it. So we do have all these values now. I can just simply copy from a command history all the arguments which we have simply just filled in and go ahead. Yeah, that doesn't seem very good. Okay, maybe we should create another output. And for that, we're going to go ahead and list and spend outputs and see what we can do here. So let's see. Spell. Okay. So this looks like a change output from a transaction with a spell. It, by the way, is the transaction that created the xBTC batch. They minted the xBTC originally. So we're going to take this output and split it into two. Okay, we're going to use this create raw transaction CLI command here. So we're going to take this transaction ID, put it here, and we're going to, which one was it? Number one. Um, and recipient is going to be simply um, get new address command here. And we are going to go ahead and say, let's put in a 2000 sats here. And yeah, let's maybe create another one of these. And just in case another one. Okay. All right. On draw transaction. Okay. Sign draw transaction with wallet. Okay. 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 That should do it. Okay. So now on draw transaction. All right. Oh, I've created a bunch of outputs of 20,000 sats instead. Whatever. Okay. What we absolutely know that this transaction does not carry any spells because it's a simple transaction. Um, okay. Well, what we will put in here is that export equals let's see which one of its outputs we want to abuse. Number 0 and export hash here. It's going to be HU of this. And let's see now. Okay, spell sec on Cardano. Oh yeah, we haven't changed the previous transactions. That needs some correction here. Pre transactions equals okay. So the first one is the Cardano transaction. The second one is going to be this transaction. So I'm going to go ahead and simply take it. Okay. So just to double check, let's look at that Cardano transaction. Oh, it doesn't look good. It doesn't look good at all. Oh, yeah. I see why. Huh. Oh, that's better. Okay, now. So spell check. Okay, let's see. Uh, looks good. Let's go ahead and spell prove. Okay. So we changed previous transactions. We changed we don't need to change funding UTXO, or do we? Funding UTXO. Oh, right. We didn't change that on Cardano. We changed that on Bitcoin, so we don't need to change it. But let's just double check. So this is the funding UTXO and funding UTXO value. Okay. And let me just go and quickly consult with my Cardano Explorer. It looks good. So, okay, let's try it again. Actually, also, oh, I see. I misspelled change address. How embarrassing. Equals. I did indeed misspell it. Okay. Okay. I believe now it should work. Okay. So apparently I made a mistake uh, because we are not spending a beamed output, but we are rather beaming into another chain. We don't need to specify the transaction that generated that a placeholder UTXO that we are beaming into in previous transactions. And that's why the proof was failing. Now that I removed it, it works perfectly. So as you can see, this is just a Cardano transaction here and no Bitcoin transactions here. This is the Cardano transaction that generated this output here. So looks like proof is succeeding. All right. So we got the proof. And let's save this into draft JSON here. And okay, so wallet directory equals, okay, which one? So we are sending from handle, therefore we're going to go ahead and copy that directory. And let's go ahead and sign. Um, okay. And let's see now. Use sign transaction and I guess submit. Yeah. Okay. We have just beamed xBTC back to Bitcoin. And now the last part of this exciting journey is to burn the xBTC and the batch NFT to finally be able to redeem back the locked actual 1 Bitcoin. Let's see. Okay. So let me first copy all of this into the demo log here. I'll deal with cleaning that up later. And let's see here. Okay. All right. So what we need here is this transaction ID. Next. So that would be the transaction that we've sent on Cardano to beam back. So let me check. And I do see the change amount here is 9 ADA 745,999 Loveless. I will go ahead and take a look at that in the uh, but yeah, I should look at that in the boss handle wallet. So let's see. Okay, I do see that. So I've got the transaction ID. Okay, just to make sure that's the right transaction, let me just fetch it by ID here. And oh, that's interesting. And let's just do show spell on this transaction. And it should tell us exactly what we need to know. Okay. And if yeah, so let me just quickly check it. Okay, that's the one. And yeah, that looks correct. So let's continue burning. Okay. So what we need is we need the batch NFT. I believe we already have it. Let's double check. We do. And I also believe we already have this. What else? I think what we're missing is this address 4. Let's get new address. And from the looks of it, we can simply bounce xBTC or hopefully there's no nulls in here. It doesn't look so. Okay, so let's see what's going on here. So in the inputs, we have 2 inputs. One has the xBTC batch with one xBTC. We have our one xBTC here, the fungible token, and it's beamed from Cardano to us here. So this is the Cardano transaction output that beamed this thing to us. We can quickly check. This is the output of that transaction. So it's the output number 0, and this is the transaction ID. Okay. So let's go ahead and do the regular procedure. Turns app run. Okay, so both contracts for the batch NFT and for the fungible token are satisfied. Let's check the spell. Okay, and since we are on Bitcoin, we don't need to provide the previous transactions. Oh, actually, we probably do, because in this case we do, because we cannot fetch a previous transaction from Cardano by using Bitcoin CLI. So I'm afraid we're going to have to do that. Okay. So I'm going to cancel here and see. Okay, so the TX2, first of all, um, or rather, not TX2, no. Okay, it's TX1 actually. And okay, so for this, we simply need to fetch these transactions. Let's do that one by one. I'm gonna get raw transaction. That's the transaction ID. That was the first one. Now the second one. Then directly into the clipboard. And the third one is the one on Cardano. Okay, so this one, yeah, let's just actually take it from the API. I think that should work best. Okay, it's a massive environment variable. Okay. So what are we doing? We're doing this. I'll check. Wow. Okay. Mm, mm, we need a funding UTXO for this. Um, Spellcast. Yeah, just a funding UTXO. Okay. So for the funding UTXO, we're gonna go take list and spent outputs. And I think we have a bunch of 20,000 sats. That should be sufficient. Okay. All right. Oops. What's wrong? Okay, so I had to patch the charm CLI to accept the particular charm spellcast subcommand to accept previous transactions. Now it's optionally accepted. If it's not provided, it's they are gathered automatically on Bitcoin. But if they are provided, they are respected. And now we are successfully generating the proof for the burn transaction. And let's see what happens. Okay, so the final proof is getting created. And at this point, we know it's correct. We know the spell is correct. All right. So let's just, okay, let's just check this one real quick. Spell. All right. Okay, so what's happening here is that the output, the only output doesn't have any charms, and it's spending these two inputs with charms. The two charms being the Batch NFT and the xBTC. Um, okay, let's go ahead and submit. Okay. So now, uh, uh, okay, there we go. That transaction is now, well, probably not yet confirmed, but draw transaction, and let's see. And let's see. Okay, so at this point, what we have here is we have submitted the last transaction with a spell, which is when we are burning the xBTC. And the last step is to submit the proof of this to Bitsnark and unlock the locked 1 BTC and send it back to where it belongs. And that will complete our journey that we took today.